Okay, so today we're solving multi-step equations, and you'll notice that I have a list of steps for us to follow. So we're going to start with those. Step number one being clear the equation of fractions and decimals. Now, if we go ahead and just take this list down, and we'll be doing problems that will show us what we mean by that. Number two, use the distributive property to clear parentheses. Not every problem will have them, but if they do, this would be the time to take care of those. Number three, combine like terms. We're going to combine the like terms on both sides of the equation. Number four, now we get into undo addition or subtraction. And number five, undo multiplication or division. Okay, so let's swim on over here and let's just start looking at a couple of problems. We'll start with 3x minus 4x plus 6 equals negative 2. Okay, now this does not have any fractions or decimals, and there are no parentheses, so we're going to start here on step 3. We're going to combine like terms. We have 3x's and we are taking away 4x. So that's going to leave us with a negative x. We know that to be negative 1x plus 6 equals to negative 2. We are now going to go ahead and undo our addition here with our subtraction. So we are going to subtract 6 from both sides. This gives us a negative x equals negative 8. Now, normally I would ask you, are we done? And your answer would be, no, we are not done. We have got to take care of that. And then I would say, oh my gosh, you're a star. Yes, you know that we can never have a negative x. What? No, we can never have a negative x. So, you're a star. We know that. Now, there's two ways to take care of this. We can either multiply both sides by negative 1, or we can divide both sides by negative 1. I'm going to go ahead and multiply by negative 1, and I'm going to say negative 1 times negative x gives me a positive x equals negative 8 times negative 1 equals a positive 8, so x equals 8. Let's go ahead and let's check that, okay? So we have 3 times 8 minus 4 times 8 plus 6 equals negative 2. So this is 24 minus 32 plus 6 equals negative 2. Move that down a little bit. And here 24 minus 32 is a negative 8 plus 6 equals negative 2. And yes, it does. So a nice check at the end doesn't really hurt. It can only help. So that is one of our simpler multi-step problems. Let's go ahead and try one that has maybe a little more to it. So let's solve one with grouping symbols. Let's go back up to the top of our paper here, and we will have 3 times k plus 8. We will add, we will say that that is equal to 21, okay? So clearly we have a distributive property issue here, so we're going to go ahead and distribute that 3. So we will end up with 3k plus 24 equals 21, and now it becomes just a regular two-step problem. We are going to subtract our 24 from both sides, leaving us with 3k equals, and 21 minus the 24 is going to give us a negative 3, dividing both sides by 3, giving us k is equal to negative 1. And once again, if you have any questions or doubts, you should always follow up with just a really quick check. This would be so easy to just say negative 1 plus 8 equals 21. This becomes 3 times negative 1 plus 8 is 7 equals 21. It's absolutely a very fast check. Okay, so let's get into something a little bit more complex. Not really, but we're going to just go to fractions. So let's look at a problem with fractions. M divided by 4 plus M divided by 2 equals 5/8. Now, the big thing here is that when we deal with variables in fractions, it does get a little bit more complicated, so sometimes we like to get rid of that denominator. So in this case, I want to get rid of these denominators here. So I'm going to go ahead and I'm going to multiply everything times 4. Okay, so I am going to say 4 here. This is going to give me 4m over 4 plus 4m over 2 equals 4 times 5 is 20 over 8. Notice all of my multiplication is being done in the numerator. We know 4 divided by 4 is 1, so I have just 1m there. 4 divided by 2 is 2, so here I have 2m equals 20 over 8. We will take care of the improper fraction in just a moment. Okay, this becomes 3m equals, and we're going to go ahead and we're going to, well, we can certainly leave this as 20 over 8. And we're going to now go ahead and divide both sides by 3. Now, remember, this, we're going to rewrite this, okay? This is going to become m equals, and let me just move down a little bit, 20 over 8 divided by 3, okay, which is equal to 20 over 8 times 1/3. Okay, so this gives us 20 over 24. So m equals, and I'm going to go ahead and simplify this, and of course you can do it by finding your common factors or whatever. I just usually say half of it's 10 over 12, half of that is 5 over 6, and that is where I'm going to leave it. So m is equal to 5 over 6. Once again, you can put that back in and check to make sure that you are doing it properly. So you are making sure that you are multiplying times a number that is going to give you or take away your actual fractions. Okay? Let's look at a second problem like that. Okay, and possibly you may want to pause as I do this and see if you can do it on your own. So we're going to do 2/3 x minus 5/8 x, and that's going to equal 26. Now at this point, if you want to go ahead and pause, and then I'm going to go ahead and continue, but if you pause now, do it, and then rejoin me, you'll be able to see how it goes. So I need to multiply both sides of these by a number that will get rid of them, in essence. So I need a multiple of both. Now, if we look at 8, when we look at our multiples of 8, 16, still not divisible by 3, and then we go to 24, which is divisible by 3. So I am going to now multiply everything times 24, okay? So 24 times 2 is 48 divided by 3x minus 24 times 5 is 120 over 8x equals, and then 26 times 24, 2, 8, and that's 10. 2 times 6 is 12, 4, 5, That gives me 4, 2, and 6. So that's 624. Okay, 520. Yeah, 120. Okay, now 48 divided by 3. 3 goes into 4 once with 1 left over. So that's 16x minus 8 goes into 12 once with 4 left over. So this is 15x equals 624. 16x minus 15x is 1x. So x is equal to 624. Okay? So hopefully at this point you've rejoined us and you are looking at the answer, and hopefully you came up with the same answer as I did. Now, if we're going to work with decimals, we can also get rid of those decimals. So let's look at 0.025x plus 22.95 equals 23.65. Now, the goal here is to multiply times a power of 10 that will actually get rid of the decimals. In this case, we have numbers in the tenths, the hundreds, and the thousandths. So I have to multiply everything times the 1000 in order to get rid of those decimals. So having 3 zeros means that I can move this 3 places, which gives me 25x, plus here I'm going to move it 3 places. So that means I'm at 22, 950 equals, and doing the same thing here, 23, 650. Hopefully everybody understands how that moves, because 1, 2, and then 3. I've got to add that 0 on the end of both of those. Now, subtracting 22,950. Okay, this cancels out, leaving me with 25x equals, now I'll do my subtraction here, 0 minus 0, 0, 5 minus 5 is 0. Here I'll borrow, and I get a 7, okay? So I'm left with 25x equals 700, and we're dividing both sides by 25. And an easy way to do this, of course, is that I know that there are 4 25s in every 100, so 4 times 7 is 28. I could have also done a little bit of division and said 700 divided by 25. 25 will go into 70 twice. That's 50. That leaves me with 200. And I do know that 4 25s in 100, so 8 25s in 200. And so there I have my 28. So x is equal to 28. So the important thing to remember here is to multiply times the power of 10 that will get rid of all of your decimals. Okay, so that looks like all of the information for this section. Hopefully you're all going to be great stars when you work the problems tomorrow. Have a great evening.